Good afternoon, ladies and gentlemen. I am your host, Gordon Zulu. So for today, we'll be looking at what is called the internal rate of return, where we know to say the internal rate of return is a discount rate that makes the net present value of all cash flows equal to zero in a discount cash flow analysis. So when we are dealing with what is termed as the IRR, we need to note that the IRR is calculated using the same concept as the net present value, except it sets the net present value equal to zero. So we know to say in the previous video, I showed you in how to calculate the net present value. So we'll look at one question in where the net present value was already calculated and where the net present value was greater than zero, where we said to say if it is greater than zero, then a project is worth taking. So with me, I have one example which I want you to see, which is, so this is the example that I have where we have the year and the cash flow. Given the cost of capital to be 14%, calculate the net present value, where the net present value here was already calculated. Since we have assumed to say now we all know how to calculate the net present value, and the decision was made, which is to accept the project. Why? Because the net present value was greater than zero. So this was the answer to it. So this was the answer to the net present value, where we had the answer to be 8,430. And we know to say if the net present value is greater than zero, then the project is worth it taking. Then the concept of calculating the internal rate of return, it relies on this value. How does it rely on this value? We need to understand to say how close is this value close to zero, that you can try and error to estimate the discount factor or the internal factor. So one thing you should know is that the relationship between the discount factor and the net present value is inversely proportional. If I was to increase the discount factor, I will decrease the net present value. So with me, what I always do is I always add plus or minus 10 to the discount factor I'm always given. The reason being is I want to, by all means, to be very fast with my working. Why? Let us assume to say this number was negative. If this number was negative, then I need to reduce this discount factor for me to get the positive number. Remember, I said the relationship is inversely proportional. So if this number is positive and you want it to reduce it to negative, then you should increase the discount factor. So let us draw a table trying to estimate. Let us increase the 14% to 20%. We see if the net present value will change to a negative. So let us try to use 20%. So we'll try using 20% in calculating the net present value, where we know to say the method is still the same. Remember, in our first statement, we said the IRR is calculated using the same concept as net present value, except it sets the net present value equal to zero. So you will find the discount factor for this, where we say this is always 1, then this times that one is 31,000. The method is still the same. So if you calculate the net present value for this box using 20%, these are the results that you are going to get. So if you calculate the net present value using 20%, you will get this as your positive. Then we should know, when we are calculating the internal rate of return, always you need to have one net present value which is positive and the other net present value which is negative. So using 20% as your discount factor only reduced the net present value but did not make it a negative. So the reason why you want it to make it negative is because we want, as when we do the calculations using the internal rate of returns formula, we find the other percentage, where that other percentage, when you use it for calculation, the net present value will be an estimate of 0. So this 20% has failed, but it has only reduced. So let us again use another. That's why I have said when we are calculating the internal rate of return, always try by all means to increase the discount factor with a higher margin when your net present value is positive, and always try by all means to reduce the discount factor by a higher margin when your net present value is negative, so that you increase it. So let us try maybe 25, 24, or 27 in calculating the internal rate of return. Remember, this is a try and error, but with me, I will specifically use 27. Why? Because I love increasing my discount factor with a higher margin. So if we use 27, let us again draw the net present value. So this box has become invalid. Why? Because you cannot use it any longer, because the net present value it gave you is positive, and that present value you had calculated using 14% was positive, and you can't use the positive net present value with that other positive net present value. So here you need now to calculate another net present value using the other discounting factor. In this case, we have said 27. So you need to make yourself familiar now, and you need to be very fast, because remember, it's a try and error thing. You are not accurate to say immediately use this in discount factor. Will my net present value be positive, or will it be negative? So you need now to be very fast when using your calculators. So we now calculate the net present value using 27%, where we know to say this times that one is still this amount. Where we go for number 1, here it was a 10,000. Then remember the formula for us to find the discount factor. We said it is discount factor is equal to 1 over 1 plus r to the power n, where r is the rate you are given. So in this case, you are given 27, you change it to decimal, giving you 0.27, where the number of years is 1. So 1 divided by 1.27, you are getting 0.7874. 0.7874. So it is what you will put here, 0.7874. Then you multiply this with 10,000, giving you 7874. So you use the same approach in calculating for the rest of the values, and this is the answer that you are going to find. So this is now the answer you have found when you have used what? 27%. So now what happens is this. So you will use this negative. Remember, brackets in business mathematics or business studies itself denote that this number is a negative. So now you will use this negative number, which is the net present value, together with that other positive net present value to estimate the internal rate of return, where the net present value is equal to 0. So when you are using the internal rate of return, the formula that we are always using is, so when you are calculating the IRR, this is the formula. Remember, the first net present value we had found is 8,430. So you put your 8,430, then you get your R2, which is the rate you had used for you to get the second net present value. In this case, we got 27%, minus where the net present value you had found in the second. Remember, it was a negative 486, multiplied by the first rate you had used for you to get 8,430, which is the first net present value. In this case, it was 14%. Then over where we have the first net present value to be 8,430 minus 486. So here you just punch directly where our answer is 276.1. Again, you punch negative 486 multiplied by 14%, giving you negative 68.04. Then remember, these two will add. Remember, negative times negative, that is positive. So that will add, giving you 8916. Then from here, you multiply this, negative times negative, giving you a positive again, divided by 8916. So you will just go directly by adding and dividing. So 2276.1 plus 68.04 to give you an answer divided by 8916, where your answer will be 0.2629. So from here you will multiply this by 100% so that you change it to the rate, giving you 26.29%. So if you were to try out this answer, which is the internal rate of return, it will give you an estimate close to 0. So this is how you calculate the internal rate of return. Thank you.